Welcome to Muromax. Today let us discuss a problem from the topic multiple integrals. So the question is, by changing into polar coordinates, evaluate the integral 0 to 2a, integral 0 to root of 2a minus x square. Integral function is given by x square plus y square dy dx. So we have to convert all the variables into polar and then we have to evaluate the integral. That is, we should convert the limits as well as the integral function from Cartesian to polar. That is, from Cartesian x comma y to polar r comma theta, and then we have to evaluate it. Right. So let us first write the given integral function as some I. Let I is equal to integral 0 to 2a, integral 0 to root of 2ax minus x square, integral function x square plus y square dy dx. Here the limit is given in terms of the variable x, which means that it is the limit of y. This is the limit of y and this is the limit of x then. So the limit here is given in terms of x, which means that which is the limit of y. So obviously the other one becomes the limit of x. Now finding the region of integration. Region of integration before moving on to transformation from Cartesian to polar. Region of integration. So here x varies from 0 to x is equal to 0 to x is equal to 2a. X is equal to 2a. Y varies from 0 to y is equal to 0 to y is equal to root of 2ax minus x square. Now rewriting this alone as y square is equal to 2ax minus x square. I have squared both sides. So we get y square is equal to 2ax minus x square. Again rewriting this as x square minus 2ax plus y square is equal to 0. X square, I have taken all the terms to the LHS. X square minus 2ax plus y square is equal to 0. So this is nothing but equation of circle. Where we have to find the center and limit. To find the center and limit, x square minus 2ax plus y square is equal to 0. We should convert it in the form of sum x minus h the whole square plus y minus k the whole square is equal to r square. This is the general equation of any circle with center h comma k and radius r. Radius r and center h comma k. So the general equation of any circle with center h comma k and radius r is given by x minus h the whole square plus y minus k the whole square. So we have to convert this equation in this form. So to convert it, only then it is possible to find the center and radius. This is the generalized one. We have to only, if we convert this general equation in this form, it is possible to get the center and radius. So to convert this equation in this form, considering the coefficient of x is 2a, dividing that by 2, this is coefficient of x is 2a, dividing by 2. When we divide it by 2, it is just a. Squaring it. When we square it, it is a square. Now adding and subtracting that a square to this equation, that is x square minus 2ax plus a square minus a square plus y square is equal to 0. Because y square, we can take this as it is, but this x term alone we have to convert it in the form of x minus h the whole square, because y square maybe we can take it as y minus 0 the whole square. In that case, the center k value becomes 0. But here x term alone, it is of the form x square minus 2ax. So to convert this in the form of x minus h the whole square, we have considered the coefficient of x. Consider the coefficient of x, which is 2a. Divide that by 2 gives you a. Square it, we get a square. Add it and subtract it. So this term alone becomes x minus a the whole square. X minus a the whole square. So when we expand it, x square plus a square minus 2ax. Using the formula a minus b the whole square. We know that a minus b the whole square formula is a minus b the whole square is a square plus b square minus 2ab. Right? So a square plus b square minus 2ab can be written as a minus b the whole square. So similarly, this is reduced to x minus a the whole square. And this y square comes as it is, plus y square, and this minus a square to be taken to the RHS, which is equal to a square. So finally, comparing this along with this equation, when we compare, we get h is equal to a, k is equal to 0, and r is equal to a. That is, center is a comma 0, radius is a. Right? So this equation becomes this way. This equation becomes x minus a the whole square. Again, this becomes x minus a the whole square plus y square is equal to a square. Center is a comma 0, radius is a. Now representing this in graph, representing this region in graph. Center is a comma 0, radius is a. Origin, x-axis, y-axis. Center is a comma 0. Let it be somewhere here. X is equal to a. So this point be a comma 0. And radius is a. Radius is a means it should be 2a here. 2a comma 0. Right? Only then if we draw, it becomes like this. Somewhat like this. So here it should be 2a comma 0, because we know that if the radius is a, then the diameter becomes 2a. If the radius is r, then the diameter becomes 2r. So here the center is a comma 0. Here this point we have taken it as a comma 0. Center becomes a comma 0. Right? So radius is a. So this distance is a. So this distance is also a. So a plus a becomes 2a. So this distance is a, as well as this distance is also a. Radius. So a plus a, this point becomes 2a comma 0. So circle we have drawn it. Now x is equal to 0. X is equal to 0, we know that, which is nothing but y-axis. X is equal to 0. Then x is equal to 2a. X is equal to 2a. So x is equal to 2a is a straight line at the point x is equal to 2a parallel to y-axis. Parallel to y-axis. So this line is x is equal to 2a. This is also over. So x is equal to 0 is over. X is equal to 2a is over. This circle is also over. Now y is equal to 0. Y is equal to 0 is x-axis. X-axis, y is equal to 0. Now the region of integration is the bounded region or the intersecting region. So x varies from 0 to 2a. That is, from x is equal to 0 to 2a, from x is equal to 0 to 2a, x is equal to 0 to 2a. So from here to here, from here to here, from here to here, from here to here, it goes on like this. It goes on like this. This is over. Next, from y is equal to 0 to this circle. From y is equal to 0, y is equal to 0 is x-axis. From y is equal to 0 to this circle. So from here to here, 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 from y is equal to 0 to this circle, equation of circle. So this is also over. So intersecting region becomes the region of integration. Intersecting region is, so this becomes the intersecting region. This is the intersecting region. So this is also over. Region, we have drawn it. Region of integration, we have drawn it. Now in the case of polar, transformation is given by transformation, that is transformation from Cartesian to polar is given by x is equal to r cos theta, y is equal to r sin theta, dx dy is given by r dr d theta. This is the transformation from Cartesian to polar. X is equal to r cos theta, y is equal to r sin theta, dx dy is given by r dr d theta. Right, transformation, we have written that. Now we need limit of r and theta. As we are transforming from Cartesian to polar, we need the limits of r and theta. To find limit of r, we do not consider strip parallel to x-axis or y-axis in the case of polar. Only in the case of Cartesian, we consider strip parallel to either x-axis or y-axis respectively. To which variable we integrate first. Respectively, we consider strip parallel to x-axis or y-axis in the case of Cartesian. Whereas in the case of polar, we consider a straight line from origin to the curve. We consider a straight line from origin to the curve. The initial point which lies on the origin becomes the lower limit. The final point which the line touches the curve, the equation of curve, becomes the upper limit. So the limit is limits initial point r is equal to 0 because it starts from origin, r is equal to 0. Final point lies on the curve, and equation of this curve, equation of this circle, we know it is, equation of this circle is x square x minus a the whole square plus y square is equal to a square. So we need it in the form of polar. We need this in the form of polar. So x minus a the whole square plus y square is equal to a square. When we substitute the values, maybe we can substitute it here itself. We get r square cos square theta minus 2a r cos theta plus r square sin square theta is equal to 0. Even if we substitute in this equation also, we will get the same result. So r square cos square theta minus, I have substituted in this equation. Just for simplicity, I have substituted in this equation. Even if we substitute in this equation also, final answer will be the same one. So r is equal to, x is equal to r cos theta. So r square cos square theta minus 2a, x is equal to r cos theta plus y square, y is equal to r sin theta. So r square sin square theta. Now these two becomes, these two, combining these two becomes r square inside cos square theta plus sin square theta. minus 2ar cos theta is equal to 0. So this becomes 1 because we know that cos square plus sin square is equal to 1. So we get r square minus 2ar cos theta is equal to 0. Again, when we take r as common outside, we get r minus 2a cos theta is equal to 0. Right? And finally, when we equate those two terms to 0, r is equal to 0 and then r minus 2a cos theta to 0. We get r is equal to 0, r minus 2a cos theta is equal to 0. From that, r is equal to 2a cos theta. R is equal to 2a cos theta. That is equating. We have two terms here, r and then r minus 2a cos theta. We have two terms here. When we equate those two terms, we get r is equal to 0. When we equate this first term to 0, we get r is equal to 0. When we equate the second term to 0, that is r minus 2a cos theta is equal to 0. From this, we get r is equal to 2a cos theta. So equation of this circle in polar becomes r is equal to 2a cos theta. So from r is equal to 0 to the curve, equation of this curve in polar is r is equal to 2a cos theta. So r is equal to 2a cos theta. Right. So limit of r is over. Now limit of theta. When we check the region, theta varies from here to here. Theta varies from here to here. That is complete first quadrant. So theta varies from 0 to pi by 2. So limit is over. Now integral function. We have to convert this integral function also in polar. So x square, integral function is x square plus y square is equal to x square plus y square. X takes the value r cos theta. R square cos square theta plus r square sin square theta, which is nothing but just r square. R square is common. Inside we get cos square plus sin square, which is equal to 1. So finally we get r square. So integral function is r square. So let this be equation number 1. Substituting all this in the equation number 1. So 1 implies I is equal to double integral function. Integral function is r square. So r square conversion transformation dx dy is given by r dr d theta. So r dr d theta. Limit of r is 0 to 2a cos theta. 0 to 2a cos theta. Limit of theta is 0 to pi by 2. Limit of theta is 0 to pi by 2, which is equal to integral 0 to pi by 2, integral 0 to 2a cos theta. This becomes r cube dr d theta, which is equal to integral 0 to pi by 2. Integration of r cube is r power 4 by 4. Limits 0 to 2a cos theta. Left out one d theta, which is equal to 1 by 4. I have taken this constant 1 by 4 outside the integral. 1 by 4, integral 0 to pi by 2. R takes the value 2a cos theta. Upper limit is 2a cos theta and we have to substitute this for r. So 2a cos theta whole power 4 minus 0. Lower limit is 0. Even if we substitute, we get 0. So omitting that. Left out d theta, which is equal to 1 by 4. 2 power 4 is 16. 16 a power 4 integral 0 to pi by 2 cos power 4 theta d theta. And here we are going to apply a formula. Formula is integral 0 to pi by 2 either sine or cos power n theta d theta. Value is given by n by n minus 1, n minus 2, n minus 3, n minus 4, n minus 5, etc. up to 3, 2, 1 in the case of odd, n is equal to odd, and in the case of even, it becomes n minus 1 into n minus 2, n minus 3 into etc. It becomes 4, 3, 2, 1 pi by 2 in the case of even. N is equal to even. If n is even, then the formula becomes this one. Starting from the n, we have to reduce it. n minus 1 in the numerator, n minus 2 in the denominator, n minus 3 in the numerator. It goes on, and finally after this 1, we have to multiply pi by 2 in the case of even. In the case of odd, it is enough if we stop up to 1 in the case of odd value of n. And the limit has to be pi by 2 definitely, for sure. To apply this formula, limit should be 0 to pi by 2, and only for sine or cos. For both the trigonometric term, it is applicable. This formula is applicable, right? which is equal to we can cancel this 4 and 16. We get 4a power 4, 0 to pi by 2 cos power 4 theta d theta. N is even here. Starting from 4 in the denominator. 4, 3, 2, 1. As it is even, we have to multiply by pi by 2. That's it. Which is equal to 4 is cancelled. We get 3 pi a power 4 by 4. 3 pi a power 4 by 4. This is the value of the required integral. Thank you. Let us meet in another problem.